Hey, what's up everybody? This is Cam with Danomics. In this video, I'm going to go over how we do a spatial-based normalization in Danomics. So, curve normalization is obviously really important if you're doing multi-well petrophysics, if you're doing log correlations and whatnot. And there are a lot of different ways that we can do normalization in Danomics. We have options to do key well normalizations where you can, let's say, align all the wells so their P50 were to match, or to stretch and squeeze them so that the P10 and the P90 are all aligned on these wells. We can also do spatial-based normalization. And the benefit of spatial-based normalization, even though it does take a little bit more work, it's more than one button click, is that it preserves the geological trends within our data. So this video will review the steps on how we do that. So first thing we will need to do is we'll need to create a petrophysical interpretation. So do that with File, New, Petrophysical Calculation. And once you've done that, you'll need to come over here and choose your well header, your well log, and your well tops database. And as usual, we will also select a well to be our key well here, which I have already done. Now, once you've done that, there's really only one more thing that we need to do before we start the normalization process, and that is to define our statistics window. There's two ways we could do that. We could come here to the setup module, and we could define our stats window start and end. Recommended values here are relative to first formation and end of available data. And the reason we set the statistics window here is we don't necessarily want to use the statistics from the well log all the way to the surface, because a lot of times you may have shallow, unconsolidated sediments. So we want to maybe omit some of that part of the log. But what I'm going to do is I'm going to set it via the quick start module. And the reason I do this is I can just come here to well faults, or well defaults. I can then select one of the options. In this case, I'm going to select type reservoir. And this not only sets the statistics window, it also sets about 30 other parameters that are going to be important later in my interpretation. Okay, so once I've done that and I save it, I'll then need to create a new flow. If you've never made a flow before, it's just File, New Flow. Now, I've already constructed this flow for us here, and I've called this my norm endpoints flow. And this flow has a number of tools. We're going to start by adding a log input tool. In this case, I'm selecting some wells from the Midland Basin. I'm then adding a CPI log calc tool. This is the tool that does a lot of the heavy lifting for us here. Within this tool, I will add a number of equations here. So for each of the logs that I want to normalize, I'm going to be adding a P5 and a P95. So I'm doing this for gamma ray, PE, and neutron, because those are the ones that I'm thinking about normalizing here. And the formula we're using is by stats window, give us the percentile, in this case the 5th percentile of the gamma ray comp curve. In the help article on the website for spatial-based log normalization, we have all these equations available, so don't worry about scrambling to write these down. Those are available in the help article. Now, once you've done that, you're going to set the output to points, 1 per curve. You are then going to select your CPI file, your tops, well headers, and your log database once more. Okay, this will then calculate the P5 and the P95 in the statistics window for each of these curves. And it's going to write out a set of points. So points will be what comes into the next tool. And now we're going to use point spatial filtering. So what this does is for each of our properties, it's going to look at a certain number of neighboring wells, and it's going to say if the target well that we're looking at falls outside of a certain statistical range, we're not going to use that for gridding. So if a well falls outside the P10 and the P90 range of its 21 closest neighbors, that well will be omitted. And what this essentially does is it applies a spatial filter, so it's removing the outliers from the map. Okay, once we've done that, we will then need to grid it. For the gridding, you can pretty much leave this set to the default. I have selected a somewhat different gridding method here, so I've selected minimum slope. You can select whatever you want. You can also set the resolution. I've upped mine slightly because I'm looking at a fairly large area, so I've set it at 512 pixels, so that's a 512 by 512 grid. I'm then applying a light smooth, and then I'm writing out a grid called norm endpoints.grid. Now to run the flow, you would just come here and click the run arrow or go flow run. Now I've already ran the flow, and it has written out this norm endpoints.grid file, and that's what I'm now going to use to drive my normalization. So I'm going to come back to my CPI. I'm now going to go to the curve normalization module, and I am going to select scale to fixed range, and I made grids of the P5 and P95. So I'm going to put for my low percentile a value of 5, and for my high percentile a value of 95. Now for the values, I need to use my grids. So I'm going to hover over my parameter box for the low value, and then I'm going to click the gear icon that appears, select interpolated table, select my norm endpoints grid, and select my gamma ray P5. It'll give me a preview of the grid, then I'll hit OK. Then I'll repeat that for the gamma ray high value, where I hover over the box, click the gear icon, select interpolated table, choose my norm endpoints grid, and select my gamma ray P95. Now that I've done that, we can see that the well has been slightly normalized, where we can see that the gamma ray, the lows are a little bit higher and the highs are a little bit lower. And if I want to see the effects of this across the board, it's useful to go to something like the cross-section tool here and choose, let's say, the gamma ray normalization QC template. And what we can see is that a majority of the wells here have very little normalization applied to them. Here we have a well that's undergone significant normalization, and then we have a number of wells that have minor normalization again. And we can see that most of the wells have experienced little normalization, but we do have a few that once again have more substantial normalization applied. We can also QC it by looking at properties like our gamma ray average map if we would like to. All right, so that is spatial-based normalization. For the gamma ray, we could repeat that same process for the neutron curve, for the PE curve, etc. It's the exact same process. We just choose the grids that we would want to use there. All right. If you'd like to do this on your well logs and you're a subscriber to Danomics, just shoot us an email at support@danomics.com and we can help you do this process. And if you're not yet a subscriber to Danomics, just hit us up at sales@danomics.com and we can get you set up to do this on your well logs. Thank you.